Are there any planets or moons in our solar system that might harbor microorganisms or life? Yes, there are planets and moons in the solar system where microbial or extraterrestrial life could potentially exist. Currently, in the scientific community, the following celestial bodies are considered to have a high potential for the existence of life. Mars. Mars is a planet similar in size and composition to Earth, and it is believed to have been more hospitable to liquid water in the past. Presently, Mars is known to have water in the form of ice beneath its surface, and there is a possibility that life, similar to Earth's, could exist there. Enceladus. Enceladus, a moon of Saturn, is covered by an icy shell, but it is hypothesized to have a subsurface liquid ocean. Geysers periodically erupt from the surface, indicating the presence of liquid water beneath the ice. There is potential for microbial life to exist in Enceladus' subsurface ocean. Europa. Europa, another moon of Jupiter, also has an icy surface covering a subsurface liquid ocean. Its surface displays numerous fractures and fissures, suggesting that water from the ocean may periodically reach the surface. Europa's ocean could potentially support microbial life. Titan. Titan, a moon of Saturn, is slightly larger than Earth's moon and exhibits Earth-like weather patterns and an atmosphere. It has lakes and seas composed of methane and ethane on its surface, creating an environment where life could theoretically exist, although in a vastly different form than on Earth. Apart from these, there are many unexplored planets and moons in the solar system. Future explorations may reveal new possibilities for the existence of life beyond Earth. As of October 24, 2023, there has been no discovery of microbial or extraterrestrial life in the solar system. However, scientists believe there is strong evidence suggesting the potential for life in our solar system. If life were to be discovered in the future, it would be a remarkable and inspiring development for humanity. So, if we transfer microorganisms such as viruses and bacteria from Earth to that satellite or planet, is there a possibility that they will proliferate? Yes, there is a possibility that Earth's microorganisms, if introduced to the planets and moons in our solar system, could proliferate. Earth's microorganisms have the capacity to adapt to a wide range of environmental conditions. For instance, the oceans on Enceladus and Europa are extremely cold and under high pressure when compared to Earth's oceans. However, on Earth, there are microorganisms capable of surviving in such extreme environments. Therefore, if these microorganisms were introduced to the oceans of Enceladus or Europa, there is a potential for them to proliferate. Similarly, the lakes and seas on Titan are significantly colder and composed of methane and ethane, in contrast to Earth's water-based lakes and seas. Nevertheless, on Earth, there are microorganisms that can thrive in such environments. Consequently, if these microorganisms were introduced to the lakes and seas of Titan, there is a possibility for them to proliferate. Of course, not all microorganisms would be able to proliferate in the environments of the solar system's celestial bodies. Microorganisms that cannot adapt to these specific environmental conditions would not survive. However, it is expected that some microorganisms could overcome these challenges and proliferate. If Earth's microorganisms were to be introduced to the planets and moons in the solar system, this could provide new clues about the potential for life to exist elsewhere. Moreover, it could lead to the development of new pharmaceuticals and food sources using these microorganisms. Therefore, research involving the transplantation of Earth's microorganisms to the planets and moons of the solar system holds significant importance. Is there an international agreement against the migration of terrestrial microorganisms to planets or satellites in the solar system? Yes, there is an international agreement that opposes the transfer of Earth's microorganisms to planets and moons in the solar system. It's called the Agreement on the Prevention of the Introduction of Harmful Alien Species into Outer Space, also known as the Outer Space Treaty. This treaty was adopted by the United Nations General Assembly on November 19, 1979, and it entered into force on February 15, 1986. The purpose of this treaty is to evaluate and manage the impact of Earth's microorganisms on extraterrestrial environments, considering the potential existence of alien life. The treaty includes provisions such as conducting scientific research to assess the impact on extraterrestrial environments, prohibition of the introduction of microorganisms, considering the potential existence of alien life. If the introduction of microorganisms is unavoidable, taking measures to minimize the impact on the environment. As of now, this treaty has been ratified by 45 countries, with South Korea ratifying it on December 21, 2000. The reasons for opposing this treaty are as follows. Concerns that Earth's microorganisms could proliferate in extraterrestrial environments and potentially threaten the existence of alien life. Fears that Earth's microorganisms could trigger new diseases in extraterrestrial environments. Worries about exposing Earth's ecosystems to extraterrestrial environments. Of course, there are also arguments in favor of this treaty. It allows for the confirmation of the existence of alien life through Earth's microorganisms. It enables the development of new pharmaceuticals and food sources using Earth's microorganisms. The effectiveness of this treaty is a subject of debate. Not all countries that have ratified the treaty necessarily comply with it, and there are no mechanisms for enforcing the treaty in the event of violations. Therefore, some argue that it may not entirely prevent the transfer of Earth's microorganisms to planets and moons in the solar system.